Hi everybody, it's Lisa, and this is the third of the three films that I'm making before class session 3 coming up next week. And in this final little film, we're going to be looking at normal distributions and learning how to interpret the data that they contain. Sorry to ask such a personal question. I don't really care whether you're normal or not. But what I want to point out is that many easily measured human characteristics are distributed in the population along a normal curve. Height, weight, shoe size, blood pressure, propensity for depression and other mental difficulties, love for Star Wars. All of the characteristics associated with child development are distributed along a normal curve, and so is intelligence. And so when I think about normal in relation to normal distribution, I would encourage you to think about most typical. So a normal curve shows what's most typical within a population. So here's a quick little review for people who skipped over that middle fun-size film. So what we're looking at now is a normal distribution. The vertical line here and the 0 represent the mean, and the rest of the data are arranged in relation to the mean. The scores that are above the mean are on the right side of the chart. The scores that are below the mean are on the left side of the chart. And the greatest number of people in any given population fall within one standard deviation above or below this mean score. So this whole block falls in that position. And the reason that a normal curve has this shape that it does is because around the mean, where most people are clustered, the graph is at its highest point up here. So I think I'll scribble on the next thing too. As I mentioned, IQ is normally distributed. And IQ stands for intelligence quotient, and when we hear quotient, we know that something's being divided by something, and that is indeed the case. And IQ is a number that is arrived at by identifying the relationship between somebody's chronological age, which would be assessed using a calendar, and their mental age, which is assessed by an IQ test. And if your mental age is higher than your chronological age, that puts you on the above the mean side of the normal distribution. And if your chronological age is higher than your mental age, that would put you on the below the mean side of the normal distribution. And psychometricians, which I think could be a really good band name, set the mean IQ score at 100, and that's how we know that 68% of the population falls within one standard deviation of the mean. Ah, yes, I can see some good scribbling is going to happen on this one. So right here, let's get this. Oh, whatever. The line that begins above the mountain and continues straight down represents the mean. And this whole area includes 68% of the population. And as people's scores vary more widely from the mean, the chunks in which they're sort of arranged get much, much smaller. So in all, this middle section had 68% of the population. And these two little wing flap deals over here, oh yeah, you can tell that I'm a statistician. Combined, that's only 28% of the population. So that's why, so these blue areas now are significantly smaller than the shaded light blue and scribble scrabble section in the middle. And between the folks who are 1 standard deviation away from the mean and the people who are 2 standard deviations away from the mean, that's 96% of the population falls into this area. So then as you go further out into, so people would describe this 96% as within 2 standard deviations of the mean. And when they're saying that, they're talking about standard deviations moving outward together to get to 1 standard deviation, and then even further to get to 2 standard deviations. What happens on one side of the mountain happens on the other side as well. So just to make sure that we're all on the same page, I want to remind everyone that a standard deviation is a number that is calculated based on the data, and these areas each of them represents 1 standard deviation, so away from the mean. So the people who are in this area are within 1 standard deviation plus or minus on above or below the mean. If we were to move out here, we know that 96% of the population falls into this box. It's 2 standard deviations away from the mean. So it's 1, 2. And when we get to these outliers here, these would be the individuals who have the highest, most exceptional mental capacities, and out here were the people who have the most limited capacity, intellectual capacity. These 2 edges here and here only comprise a small amount of the population. And if we're talking strictly about IQ scores, then we know for a fact, because the mean is set at 100 points, we know that 1 standard deviation, this distance, means that the IQ range in that first, within 1 standard deviation, is between 85 and 115. We know that because the mean was set at 100 by the psychometricians, and the standard deviation for the test that was used to make this chart, because there are multiple intelligence tests and they don't all have the same standard deviation, we know that each standard deviation counts as 15 IQ points. So we've got 68% of the population are within 1 standard deviation of the mean, and then we can talk about the 96% of the population that will have an IQ between 70 down here and 130 up here, and so on. Folks who are out here, this would be 145, and this would be 55 over here on this particular scale. And what did I say? That'd be 145? So it would be 160 way out there. So that's how it all works. And we certainly can talk more about this in class when we see each other. But I just felt like I could do such great scribbling. I knew it would make everything so easy. I hope it makes things a little bit easy at least. So I'm like you, and I always want to know, well, how is knowing this going to help teachers? How might teachers benefit from knowledge of the normal distribution? And friends, I am going to tell you the answer on the next slide. Whoa, horsey! We can't move forward until I share two important but unconnected bits of information that will help you put what we're going to be talking about into a larger framework. So just hold tight. Okay, so when I was a little kid, there used to be a commercial on TV for Trident gum. And their motto or their slogan was, 4 out of 5 dentists recommend Trident gum to their patients who chew gum. And as I got older, I thought, well, I wonder how many dentists they surveyed. And how many dentists say, well, I don't recommend that my patients chew gum at all. So it may be 4 out of 5 dentists, but how they got to that conclusion is really sketchy. And it's because statistics really represent broad general trends. A lot of the statistics that we use come from large populations or over long periods of time. So you can't always take them as complete fact. So yeah, you can go get a quarter pounder with cheese, but when you weigh that hamburger, just the hamburger, it might not be exactly a quarter of a pound. It may be 3.9 ounces and not 4 ounces. So, but for us as teachers, statistics can really help us make predictions or make some generalizations that will enable us to not have to reinvent the wheel every time we have to think something through. So the statistical principles are very useful, but they're really not going to provide you accurate, specific information about the real students in your classroom. Okay, so I already mentioned that children's development follows a set of predictable and well-established patterns. 6-year-olds around the world are most similar to other 6-year-olds. And so that child development literature was established at the beginning part of the 20th century. And about, 20 or so years after the child study movement gathered all of this info, school administrators had a big thunderbolt, lightning flash of insight, and they began grouping students into grade levels based on their age. These school administrators knew the patterns of child development, and they deliberately created curricula for 6-year-old kids that were responsive to the typical developmental levels of kids who were 6. And although that is very efficient, for some reason it strikes me as kind of creepy. And I'm not exactly sure why, but I'll think about that and maybe I'll be able to tell you during the coming week. So this information is really important too, because we're talking about being on grade level, above grade level, or below grade level in the rest of this little film. Okay, now we can get back on that little horsey and start riding forward. Remember, now we're talking only about statistics and what statistics would predict. According to the design or the build of the normal curve, 68% of students perform at levels within 1 standard deviation of the mean. And it's because the children are grouped into grade levels by age, and the academic expectations are targeted to be reasonable and attainable by students of that age. So if you had a class of 30 kids, you could expect about 20 of them to be working at grade level. Again, based on the normal curve, 96% of students exhibit skill levels that fall within 2 standard deviations on either side of the mean. See? 2, 2. So in your class of 30, we already said that 20 of the kids will be working at grade level, and you'll have 4 who are working above grade level and 4 who are working below grade level. Statistically speaking, your results may vary. To continue, just using the percentages from the normal distribution, 99.7% of students exhibit skill levels that fall within 3 standard deviations above or below the mean. So what were we saying before was 96, and now we're up to 99.7. So that's a very, very small group of students here at the lower edges and here at the upper edges. And you could go for several years without having a student in your class who is working this far above grade level or this far below grade level, because those kids are rare and exceptional. So now when we're talking kids who are within 4 standard deviations of the mean, we're looking at students who are so exceptionally advanced or so intellectually challenged that you might not ever teach a student who has this degree of intellectual exceptionality. You guys know I have a master's degree in education of the gifted, and I've worked extensively with gifted kids in many different kinds of settings. And I have met some really amazing children, but I do not think I have ever met a child who is out haunting the edges over here. Well, this is actually where I would be sitting in a big pile of blue. So, hang on just a sec. How does this information help teachers? So, statistically speaking, I know all of you are getting, most of you are getting ready to go into your placement, and so I'm just letting you know that according to the statistics that we use, 68% of your students will be working on grade level, 16% of your students would be working above grade level, anywhere from slightly above to extremely far above, and 16% of your students will be working below grade level, again, ranging from slightly below to extremely far below. And these are just general norms that can give you a sense of what you might expect when you go into your placement classroom and begin getting to know your students. So thanks for listening, and I will see all of you very soon. Bye.